optic nerves, right?
Oh, really?
But look at the olfactory bulbs coming in. Look how big they are on a sheep. It's a sheep, right? They have a good sense of smell, right? They're huge, right? So here's the brain, right?
Stand over here.
What you're seeing here, this is the dura mater. This is the meninges. Look how tough it is. It's really tough, right? And I'm going to cut that off. Now notice in the middle is the longitudinal fissure. So let's get your book out. See my book over? Can you grab that book? I think it's like 279, page 279. And we're going to go open up your books if you don't have it, because you should bring your books with you. I mean, if you have it. If you don't have it, you can't open it.
First one is what
Right. What's that? Yeah, it's one of those days for me today. This is the door. Look how tough it is, right? Tough mother, man. There's the tough mother. Okay, we open up the tough mother there, and we pull it apart, and you can see underneath. Now remember, you guys remember my crush?
Oh, Crystal.
Crystal Gale. They all remember that. They don't remember anything else but my crush. Right? So if you come in the middle here, the crystal gali would have been right around here on the bone, and this is where the tentorum cerebri connects. So this is all, this part of the meninges on the top is called the tentorum cerebri, and it comes in the center, right down this longitudinal fold. It kind of separated the right and left lobes of the brain, of the cerebral cortex. Coming back, here's your coverings right on top of everything in the bottom area, and pull it back. This is the cerebellum. On the cat, the separation between the cerebrum and the cerebellum, it's almost like plastic. It's so firm. We bring that back. We'll just take this off here. Brain surgeon, I'm not, right? Not very delicate with this.
Yeah. Poor brain.
Poor brain. Poor Abby.
Probably had a headache.
So we come through here. This here, the pituitary. Is that the pituitary? I think so. I think we got a pituitary on this guy. Yeah. Look at that. We have, most times you can't see the pituitary, but we got it right here. Let's try this. Move it off the top, buddy. I think that's the mammillary body. It's not the pituitary, I don't think. Yeah, that's the mammillary body right there. It's just very big on this one. Trying to do it without destroying the optic nerves here. Probably going to have some, yeah, see, I tore it a bit. Not doing a good job, Doc. It's too tough. Cook too much. You can dissect one if you want today. Okay? You want me to do it?
How many we got?
We got a few in there. I destroyed it, so I'm going to take that off. You see, we destroyed a lot of stuff. We took the mammillary body with it. We took some cranial nerves off with it by accident. I just wanted to get some major structures here. Okay, so here you have the cerebral cortex. Now, there's something about the brain. If you look on page, that's it, page 283, activity, no, go back. Go back. At 281, activity 1. And it describes in the bottom, identifying external brain structures. The brain is usually studied in terms of 4 major regions. The cerebral hemispheres, the diencephalon, which is inside, below the cerebral hemisphere, and then the brainstem. The diencephalon would have the midbrain, and then you have the brain stem with the medulla and the cerebellum. So this is the cerebral cortex sitting on top of the diencephalon, and then inside you'll see some things. But let's look at this. There's something about the brain that you see right away, all these folds, right? Mm-hmm. Now you have folds, and folds form grooves like sulci, which is a groove, the sulcus, and the gyri is like the mountain of it. So you have gyri and sulci, right? Or gyrus and sulcus. So here, this is the pia. I'm pulling that pia off there. See that? So what's right on the brain is the pia mater. See? It's very thin. As you pull the pia, we can go through all these different gyri and sulci. Now, this is the longitudinal fissure separating right and left brain hemisphere. If you open it up a little bit and look inside, you can see something in there. See inside there? See that white? What is that?
White matter?
No? Well, it is white matter. That's what connects the right and left side of the brain.
Oh,
Corpus callosum. Yeah. That's the corpus callosum there. And then this is the cerebellum, okay? And this would be the medulla right here. And this would be the pons in the front. Here you would see a pituitary gland coming out. And the pituitary gland is attached to the brain by a stalk called the infundibulum. This is the olfactory bulbs, the optic nerves I tore out by accident right here, the optic chiasma crisscrosses. Right behind the crisscross would be the pituitary gland coming out, and then the mammillary body I tore off by accident. Here's the mammillary body right here, and the pituitary gland would have been right here. Okay, so now on the brain we have these sulci, the grooves, and the gyri. It doesn't matter how many folds you have, that doesn't make you more intelligent. Just to let you know that. The size of the brain does not make you more intelligent. This is where size does not matter. And then the proportion of the size of your brain compared to the rest of your body doesn't matter either. And so there has been a lot of misnomers over the years that, you know, the bigger the brain, the small body, they're smarter. It's not true, like Pinky in the Brain, you know. Yeah. That's not true. It's all misnomers. As a matter of fact, cetaceans have a larger brain than we do, but we're smarter than them. They're very smart, but we're smarter than them, obviously. So the size doesn't really matter. And basically what you're seeing here, this is an animal brain, a little different shape, you notice, right? Elongated. The olfactory bulbs are really large for smell because they smell very well. They need to smell to survive in the wild, in the dark, right? And sometimes vision is more enhanced on them. And the cerebellum is usually pretty well established, and the brainstem is pretty well established on them. If you look at this picture, let's go to some image. Let me take my gloves off for a second. Yeah. Well, before I take the gloves, let me try and open this up a little bit. Is there a scalpel here? Scalpel? Nurse? Scalpel? Okay, so let's cut them right down the middle. And cut the cerebellum right in half. And cut the medulla right in half. There you go. Okay, now, what you can see here, this is the corpus callosum, right? And this is a big space. Look at that big area there. That's the lateral ventricle. Now, the brain has cerebral spinal fluid, right? It produces its own cerebral spinal fluid through ependymal cells. And the ependymal cells line what's called the choroid plexus. And the ependymal cells is going to take the venous supply of the brain, blood supply, and take that venous drainage and take the serum from that and convert it into cerebral spinal fluid. And it does it every 4 hours. So your cerebral spinal fluid is changing over every 4 hours. It's bathing the brain and spinal cord all the way down. So as it goes from the sides, you have the this lateral ventricle on either side. See it right here? Can't really see it too well on this side. But the lateral ventricle is here. This is the lateral ventricle. See how it opens up in it? That's a big space where the fluid would be. And then you go down the lateral ventricle to the third ventricle inside. And then from the third ventricle, you would go down through the cerebral aqueduct. I'm sorry, from the third, from the lateral ventricle, you go through the, hold on a second. I have to look. I forgot.